Okay, 1 minute left, just a moment. Okay, it's time. So, yeah, thanks for coming to our presentation. So let me make a presentation. Title it, Well Isolated Access Control in a Massive Multi-Tenant OpenStack Environment. So, he's Koya, and joining LY Corporation as a software engineer. And me, Yushiro, and also LY Corporation senior software engineer. So, yeah, so my recent hobby is a Rubik's Cube. 40 seconds. Okay. So, okay, let's go. Today's topic. This is today's agenda. So, in this presentation, we'd like to explain about the usage, a good usage for the load and access control by using Keystone in the huge OpenStack cluster. And first of all, let me explain about our services and private cloud. So, LY Corporation, we just the company merger from X Line Corporation and X Yahoo Japan Corporation. So the Line Corporation is a famous application is a Line as a communication app, and X Line we were using a private cloud called Veruda, and this is a totally like a huge single OpenStack cluster. And this is the X Yahoo Japan Corporation. They provide the comprehensive web portal site called Yahoo Japan, and they already also provide private cloud services for Yahoo Japan and using OpenStack. And after company merger, in LY Corporation, we needed to create a brand new private cloud, and the name is Flava. And this is of course, we are using the huge OpenStack cluster, and the characteristic is a 5-point we have. But like I don't explain about more detail. So today's presentation. Let me focus on the load-based access control by using Keystone in private environment. So here is the OpenStack roles. Let me explain the OpenStack roles in the legacy 2 private cloud and challenge for our new private cloud. So, yeah, of course, in order to control the OpenStack, we need to configure the roles for each users or each service provider, something like that. So, let me focus on the existing private cloud. So, for left side shows the Line's private cloud Veruda. So, in this Veruda, using the one OpenStack cluster and using the maybe just 5 OpenStack roles, like server admin, storage admin, network admin, something like that. And all roles are managed by a single OpenStack. So the process is very simple and easy to assign. And controls are roll across multiple cloud services and leading to excessive permissions. And on the other hand, the Yahoo Japan IRs. This is like isolated load management. So some kind of server or network, such kind of service providers are managed by OpenStack. However, the Kubernetes services, object storage, and functions, such kind of PaaS layers service providers are managed by another like identity like management platform called Athenz. So like, of course, it's clear isolation. However, the inconsistency of the private cloud. And in case of cloud operator, so kind of admin load in Veruda using the admin role in large scale OpenStack cluster, of course it's powerful and convenient, right? In case of the troubleshooting. But the serious incident caused by the mistakes, misoperation. So this is the actual incident we hit. So some user asked us, hey, please remove the load assignment, this user in this project. So the expected action is, OpenStack load remove, right? So that we can remove some load from the user. But yeah. So after that, the server admin load that has disappeared. As a result, all of the members cannot create a virtual machine. That is a significant issue. So, and that's very dangerous, right? And on the other hand, the Yahoo Japan IaaS, of course, they are using the admin role, but compared to the Beruda, so Beruda using the single OpenStack cluster, but Yahoo Japan uses more than 200 OpenStack clusters. So the permission is isolated by cluster boundaries. So some OpenStack cluster uses admin role, but some clusters are not. So in case of the negative point is hard to managing policies across the clusters. So yeah, these cloud has like the same or different kind of like negative point. So to overcome this situation, for our new private cloud, our design is a single OpenStack cluster and integrating with an authority platform except Keystone. So maybe we need to use Keystone as well as Athenz. So that is a difficult problem, like assignment for us. So the challenge is the 2 points. The first is a single OpenStack cluster for most of multi-tenant, because end user point of view, service provider's point of view, and cloud operator point of view. The second point is a centralized authority management with an authority platform. So we are using role and role-based access control. So let me explain about small 101 for the using oslo.policy, how each component can validate the operation for each role. So this is an LBaaS, role-based access control. Keystone has like a user role project. Maybe you all know about it. So let me skip this section. And first of all, the user issues a token from Keystone, and user server create a PaaS servers with token, and Nova side, each component can verify its token and extract the project ID, user ID, and roles. After that, Nova itself authorizes the request by using a policy.yaml. Hey, this node can do that or cannot do that. And the definition is policy.yaml. So this is the example of the policy.yaml. So it's very complicated. So let me pick up the one line here. And this line, server delete definition. Very, very simple. And if you join the project A and you have a server in project A, then you can delete this server. So like joining the same project, you can delete the server. This definition explains about it. And role admin can do everything. This is the definition. So like we have a policy.yaml, so we can do something. We can achieve these 2 points we were thinking, but it's very difficult because the problem one is like no suitable role for service providers. Admin is too strong, right? But the member role is too weak. So there is no the corresponding role. And the number 2 is like federation configuration. Keystone has a federation feature. So they can communicate with another platform called Athenz or other IAM platform. However, the federation configurations only federate to the other services, just enough, just only. So there is no sync feature like a user role and project. Such kind of a sync feature. There is nothing. So the default configuration cannot fulfill the requirements. To overcome this situation, now Koya will explain about how we overcome the situation. So.
From here, we will explain how well-isolated access control is implemented. Let's check the security requirements for our new private cloud, LBaaS. First, let me talk about role isolation. LBaaS is based on a single OpenStack cluster, which means there are many different kinds of access from end users and service providers and OpenStack administrators. To keep OpenStack data secure across all the different types of tenants, We carefully design how roles are defined and how access control is implemented. I will explain the approach we adopted to make sure that each role has the right level of access. First, let's discuss roles provided to cloud end users. In legacy cloud architecture, a single OpenStack role was shared across multiple cloud services. For example, the server admin role is used for accessing both the server service and other services like Kubernetes and function service. This pattern leads to excessive privileges. This has been changed as shown in the right figure. Now, dedicated roles corresponding to each cloud services are provided. This change resolved the issue of granting excessive privilege through a single OpenStack role assignment. Access of the server admin role is called and controlled by the oslo.policy framework. The policy rules for the user role are in the policy YAML file. The user role can only access resources within their own project. They cannot access the servers of the other projects. Next, let's discuss the roles for the cloud service providers to access OpenStack APIs. OpenStack provides an admin role permitting access to all APIs. All rules in the policy YAML include the admin role without any project ID constraints. So, admin role can perform operations like listing and deleting servers across all projects. The last rule is very dangerous. Therefore, we should not casually assign admin roles to cloud providers. For this concern, we provide new roles for service providers. The solution was semi-admin role. We define the server admin role, semi-admin role as being more powerful than user role, but less powerful than the admin role. The semi-admin role is created for each service provider, needing a use of more powerful API than what the user role provides. For example, cross-project resource access and permitted special APIs, like image creation API or account creation API. They are permitted. And the admin role is assigned only to OpenStack administrators and used carefully. This semi-admin role was important to achieve this privilege in Java. Let's consider server access permissions, for example. The semi-admin role is defined as in this YAML file, configuration. Look at this line. Unlike the admin role, which is permitted access to all APIs, the semi-admin role is only permitted essential APIs required for the provider service. For example, a semi-admin role for the monitoring service can list the servers of all projects. By avoiding assigning admin role, the monitoring service can access to the APIs it truly needs. This diagram shows the role structure we have been discussed. There are user roles for typical end-user access and semi-admin roles for service providers and admin role for OpenStack administrators. This role isolation ensures secure protection of OpenStack data. This table shows the number of keystone entities in Furukawa's OpenStack. Our OpenStack has an extremely large number of projects and users, so the role separation described presentation was important. We currently provide more than 15 semi-admin roles. So far, we have explained the structure and the design of the roles. From here, we dive into the lessons learned from implementation of the access control with OpenStack. First, let's discuss the implementation of the policies for the semi-admin roles, which is important for role separation. The semi-admin role requires access to resources across different projects. As explained earlier, explicit rules exist for listing servers. However, this wasn't the same with network list via neutral API. In neutral API, simply applying conditions that ignore the project ID wasn't sufficient. We needed to add semi-admin role to this context is admin rule. Like this pattern, the configuration for enabling the cross-project access to resources through APIs varies. Next, I will share an example that shows the flexibility of OpenStack. Our private cloud has the following two requirements. First, end user can create their server snapshot image. Second, end users cannot upload their customized images to GRAS. Only the OS management team can upload OS. To permit snapshot to image creation for the end user role, we needed to configure the following policies. Please look at the policy YAML file for both Nova and GRAS. But as a side effect, we cannot satisfy the requirement number 2. This rule allows users to upload customized images when they directly access the GRAS API. It seems that simply configuring the policy.yaml is not sufficient. We may need to modify the internal code of Nova or GRAS. This issue has been resolved by the X service token mechanism. Nova can include an X service token when accessing to GRAS during snapshot creation. X service token includes a service user data like Nova or GRAS. We customized to send X service token from Nova to GRAS to create a snapshot. GRAS validates the X service token and extracts Nova's user ID. Finally, we define the service user ID rule into policy YAML of GRAS. And we could control the permission. GRAS API access from the end user has been prohibited. As you can see here, the oslo.policy framework has the flexibility to implement real-world and world complex requirements. Finally, I will also present an example where oslo.policy affected API performance response times. The user role has been granted project scope access, while semi-admin role has been configured with access for all projects like this. However, one day, we received a report from the monitoring service that the response time for network list request took over than 1 minute. After investigation, the root cause was the order of the policy rule. By moving the semi-admin role to the beginning of the get network rule, the response time was significantly improved. Writing rules with broader access scope first ensures that they are evaluated earlier and behave as expected. So far, we have learned how Java implemented access control in the OpenStack cloud using auth-policy. While load separation enhances security, and managing load assignments becomes complex. To resolve this challenge, Java is based on Athenz, which is centralized authority platform. We will explain how we integrated Keystone into Athenz. Athenz is an open source LBaaS-based authority platform. It supports multi-tenancy and multi-authentication methods. Java's unified access control system is a self-hosted IAM service based on Athenz. In Java, Athenz is a single source of truth for access control information. Since Keystone manages authority in OpenStack, we needed to integrate Keystone into Athenz. I will explain how this was achieved. The first step in the integration was the identity mapping with Athenz. In other words, we needed to convert Athenz tokens into Keystone tokens. This conversion is possible through Keystone's Federation API functionality. Like this setting, we configured Athenz as an identity provider. For this identity provider Athenz, we set a federation protocol called mapd. We then define the mapping within this configuration. Through this configuration, the Athenz principal X is mapped to the corresponding Keystone user X. Then, this converted Keystone token can be used to access OpenStack APIs. The next step was synchronizing loads from Athenz to Keystone. All Java load information is stored in Athenz. We have implemented a component that synchronizes with Keystone, mapping Keystone loads to Keystone loads. This approach enables a consistent cloud authority system with Athenz. The authentication flow after integrating Athenz with OpenStack Keystone is the following sequence diagram. The user first authenticates with Athenz. The obtained Athenz token is converted into Keystone unscoped token using the Keystone Federation API. Then, user uses the unscoped token to authenticate to the project. Using the project scoped token, we can access OpenStack API such as Nova. The key point is that the authentication type specifies a PC token type. Our cloud users no longer need to manage passwords. Let's wrap up today's session. In your newly cloud OpenStack, we successfully implemented a secure OpenStack using auth-policy. During this process, we fully leveraged the auth-policy's flexibility. And integration with Athenz enables for load management. Thank you for your attention.
Any questions? Okay, go ahead.
the performance improvement you saw by reversing the order of the elements in your permission to look up list networking, right?
Maybe you're talking about this one?
Yes. So, and then, are you seeing that because you are still using the native database and schema? Just falling back on that? Do you consider actually sorting and hashing those to get better lookup time? Is there a way to do that you don't have to be conscious of how indexes are generated?
Maybe currently we're using like as-is database schema, so no customization is done. So just changing the order, and before changing the order, so like the first condition is a bit complicated, so like it took some more time, but changing this one drastically decreased. So we just observed this situation. So from our point of view, we don't customize any database schema or something, or index hashing or something. We don't change it right now. So like, I see. Yeah, that's a system.
But why is it like that? Have you tried debugging it, or maybe reporting it to different upstream? This looks like this like a bug.
Yeah, maybe it must be so, but like yeah. So just like this is the user inquiry, and quickly change this one and then solve in the plus. So that's why currently we are not checking the behavior right now. And if something needs to happen, so
please report the bug to Launchpad.
Sounds good. Okay, good. Thank you. That's good information for us. Okay, thank you guys. Thank you. Nice.